Good morning. Hello and welcome everyone. Before we begin, I'd like to do a quick sound check just to make sure you're able to hear us fine. If you are able to hear us fine, please leave us a comment in the feedback or the questions window in your BrightTalk console. I repeat, if you're able to hear us fine, please let us know in the feedback or the comments section of your console. Great. So it looks like the audio is fine. Hello and welcome everyone again. Thank you for joining us today. My name is Saurabh Kumar and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Vinod Iyengar is the VP of Marketing and Alliances at H2O.ai. He comes with over a decade of marketing and data science experience in multiple startups, built a number of models to score leads, reduce churn, increase conversion, and many more use cases. Our second speaker, Pratap Ramamurthy, has recently joined H2O. Before H2O, he was a partner solution architect at AWS, where he helped create machine learning partner ecosystem. At H2O.ai, Pratap helps customers architect the solutions on clouds, as well as solve data science problems. Before I hand it over to Vinod and Pratap, I'd like to share a few webinar logistics. Number one, please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. Number two, this webinar is being recorded. A copy of the webinar and slides will be available after the presentation is over. Without further delay, I'd now like to hand it over to our speakers.
Thank you, sir, for the warm introduction. Hi, this is Vinod Iyengar here from H2O. As sort of mentioned, I work on the marketing team and also lead some of our technical alliances. Very excited to talk today about this topic, which is extremely timely in terms of the investments that are being made by enterprises. Before we get to that, quick introduction about who we are. H2O.ai is a growing mobile open source community. We have been in business for about 7 years now. And in the process, we have created this massive ecosystem of data scientists, developers, and enterprises using machine learning in various different forms. We believe close to half of the Fortune 500 companies, including a lot of the top 10 banks, insurance, and healthcare companies, are currently using H2O open source software. We also have an ecosystem of nearly 18,000 companies globally using H2O and close to 200,000 data scientists. Those numbers I see on the slide are maybe a little dated, but those numbers keep going all the time. In addition, we have a really strong global meetup community, and our user conferences, which we do periodically. The last ones were in New York, London, and San Francisco, were massively attended both online and offline. In terms of the products, which you probably have seen from us before, we have sort of two categories of products. On the left, you see our open source ecosystem, which is basically comprising of H2O Core, as we call it internally, also popularly known as H2O3. That's the massively scalable distributed machine learning platform, which is very widely used globally. You have Sparkling Water then, which is essentially H2O Core running on top of Apache Spark. And then you have H2O GPU, where we are able to accelerate some of these machine learning algorithms by taking advantage of GPUs. All three of them are completely open source, meaning they're licensed in Apache V2, so you can take them and use them as you deem fit, build products on top of it, like many companies have done. They are built for data scientists, meaning that you can use them through R or Python, or through our H2O Flow interface, which is a very interactive data science notebook. We do offer enterprise support subscriptions for customers who wish to build their entire AI infrastructure using our open source platform, and we help them in their journey. On the right, you see our commercial offering, Driverless AI. Driverless AI is an automatic machine learning platform where we kind of take the entire machine learning workflow, data science workflow, if you will, using our learnings from the open source. We are able to automate everything from feature engineering, machine learning, interpretability, and deployment. Driverless AI is built for a wider variety of audience. We are able to democratize AI and machine learning by taking it to junior data scientists, domain analysts, even folks who are experts in statistical analysis, maybe even data engineers and developers. We automate the full end-to-end pipeline, which means that you can basically go from data to production with very little effort. And that's a commercial offering that we sell licenses for. A quick sort of overview of our H2O open source platform. So really, if you've not used this before, these are the reasons why you should consider using it. It is 100% open source. It is built to be completely compatible with the big data ecosystem, meaning we work with Hadoop, Spark, and all the proper versions that are being used popularly in the enterprise. We also support all the popular data science interfaces. That means that you can use it through R, Python, Scala, Java, or H2O Flow, which is our interactive one. At the core, really, what we're offering are smart and fast algorithms, which are completely scalable and highly performant, meaning you get the best-in-breed algorithms in a highly distributed fashion so that you can throw as much data as you want to at it. As long as you have enough compute and memory, the software will scale out basically, and use all the memory and compute available at its disposal to solve the problem. In the process, you are able to generate very highly accurate models, which are extremely easy to tune, but also you then get the artifacts, which are basically the Pojo and the Mojo, that are optimized for low latency scoring. So you can go from running on a laptop and controlling a massive cluster with a small R script, and then going all the way to production with a model that's highly optimized for it. So that's basically the end-to-end pipeline, which is being generated very seamlessly using H2O code. In addition, we've added GPU acceleration with some of these algorithms, and you'll see them in the H2O for GPU package, and they are available on all the clouds. Let's get to the topic on hand today. Right? The topic is considerations for going on cloud. So why should we care about this? Right? So if you look at some of the public research that has been put out, and no surprises, Gartner, for example, states that cloud computing and services will be a $300 billion business by 2021. So that's billion with a B. And I personally believe that's still understating the value if you consider all the ancillary services and all the support and maintenance and consulting hours that go into this. That number is probably off by order of magnitude, if you will. So there's massive amounts of investments that are happening on cloud, and everyone has kind of now convinced that every company has a cloud strategy, if you will. With that being said, what are the things that we need to think about? And we'll take a view to it today with a very sort of machine learning and AI-centric view. We can extend it a little bit more like a data-centric view, if you will. Obviously, there's enough literature out there to talk about cloud computing and cloud migration from a general purpose view, but we'll focus on the data part of it, which is where our expertise lies. With that, I'm going to bring in Pratap to sort of take over at this point. He's our in-house expert on cloud, and with many years of expertise at AWS and the floor. So he's going to take the next few slides over to talk a little bit about the cloud journeys that companies are on. Over to you, Pratap.
Well, thanks, Vinod. That's a very good transition to the next slide. That is the cloud journey. So let me introduce myself one more time. I recently joined H2O.ai. We are the machine learning, we consider to be machine learning leaders in the market. Previously, I worked at AWS. I helped build the machine learning partner ecosystem, and H2O was my first partner that I brought into the ecosystem. So very proud to be here today. Also very relevant for my background. So coming to this, the cloud journey, right? So when you are looking at a data science team that is trying to solve a certain problem, you have to look at like where exactly is your infrastructure, right? And this could be in a this is not a black or white situation. Mostly it is a spectrum, right? I have seen customers who have been in a very cloud native approach. They take a cloud native approach to being in the cloud. That is, they start with the cloud, everything, all the data is in the cloud, all the software is in the cloud. There is actually, they don't have any infrastructure on-prem, and it's completely in the cloud. Going even further to avoid any dependency with any single cloud provider, they actually use a multi-cloud scenario or multi-cloud strategy where they distribute the resources across multiple clouds, and this has several advantages as well, right? So that is what I call like top tier very cloud savvy customer, right? And where they have alignment right from the top. The second customer, or the next level, I would say, is a customer who has migrated to a single cloud. Right? They have migrated all their data. They have migrated their software applications into the cloud. Right? This is also I've seen many customers who are in this situation. But most of the customers are the third category, where they're using there is a hybrid cloud approach, where they have traditionally have had data centers, and they are in the process of migrating. They usually have a plan to migrate, a 2-year plan. They would usually hire a consulting firm to migrate their data, migrate their applications. There are several customers. This actually usually is at least a 1 to 2 year plan. And sometimes they might make that a status quo as well. That is, they would decide to have some part of their data and software in the cloud and leave some part of it on-prem. So that is also a strategy that some customers like to use. The fourth category is what I call a fully on-prem. I think it's kind of obvious here. This has traditionally been data and software in their own data centers, and it stays that way. Right? So these are all the kinds of customers I've seen and we've seen, and we support all of them. And in whatever way, whatever step or journey you are in at this point, this webinar is relevant to you, right? We have value to offer at this point, right? Going to the next slide, I want to because we're talking about the cloud and specifically machine learning workload in the cloud. Let's first look at fundamentals of why would somebody even go to a cloud, right? These are the typical 4 important value propositions of a cloud. First is CapEx versus OpEx conversation, right? Trade-off. Traditionally, if you are having your own data center, you're going to be purchasing all the hardware yourself. You're going to be paying for all the hardware upfront. Versus OpEx is operational expenditure, where you pay as you use. Right? This is compared, the very simple analogy here is the difference between purchasing a car by paying upfront versus hiring Uber or Lyft for just using, and you pay for just your ride. Right? So that is a big difference here, where you could be renting out a server for just 1 hour and paying 50 cents for that, compared to a data center where you would have to purchase a $10,000 server upfront before you can even start using it. So that's the big difference in CapEx and OpEx. And this has enabled quite a few businesses to be able to change the way they operate. Right? The second important use case or value proposition is scalability. Right? A cloud usually, the public clouds usually mean that they have data centers across the world. And they usually have many data centers in each of these regions. And for you to be able to scale, let's say you're building an application and you want to scale out your application across the globe, to be able to do that by yourself, hiring people, building out this infrastructure is probably a multi-year plan. Whereas if you are using the cloud, it's just few minutes. You can scale out your application in a few minutes across the world. So that is the kind of scalability that it provides. The third important angle is flexibility and being agile. Flexibility, being agile means, let's say, I have done this several times in my career now. That is, let's say you want to do a pilot program. You want to experiment with something to show it to your manager or management. And you start off with one instance. Right? You start off with one instance, you do certain things, and it's not fully baked, but it is a proof of concept. And you quickly build this and show it to your management, and then once you get your approval, you can then expand or scale out your POC into a full-fledged service, or you can shut it down. So the fear of running an expensive experiment is not there anymore, because your experiments are not going to cost you much. You can run an experiment for under $10, run a POC for under $100, and you can shut down if it doesn't pan out, but you can scale out and go full scale if it really works. So that is the flexibility and agility that really emboldens people to be more explorative, and experiment with newer technologies, newer ideas, that helps you to be more successful. The last thing is to be able to try out latest technology, right? Be it GPUs, be it FPGAs, or new kind of hardware, or new kind of algorithms. It's easily accessible through the cloud. And so all you need to do is sign up with your email address and submit your credit card information, and you would be able to use the latest technology within a few minutes. That is something that is also very attractive for customers. So these are the four main attractive pieces, and all seems to be aligning very well for the new generation of companies, enterprises. And so that is the reason why many companies choose to go the cloud route, right? So I want to contrast that with the value proposition of data or software on-prem. There are certain advantages for this as well, but it really that should be contrasted with the value proposition of the cloud. The first thing is infrastructure is already paid. Right? Let's say you have a data center and you've already purchased hardware. Then there is no, and you want to run a certain workload that is going to take, let's say 20 servers. Now you don't have to worry about how much is it going to be charged per day or per month, and is my CFO going to come and complain about this new expenditure? Because the hardware is already paid for. You don't have to worry about what the billing is going to be, right? It's a little weird way to think compared to the previous method, but it's more of a billing construct where and which point of the billing sale are you currently in. If you already paid for it, then there's no worrying about the cost, because you cannot overshoot your cost, because your cost of using the hardware that you already paid for is zero, right? And it's better that if you use it. The somewhat very similar second point is that if you're in the cloud, if you're running serious workloads, you need to have some kind of a cost management solution there. That is, there are now specialized partners who work on reducing your cost in the cloud, and this actually kicks in very early on. You don't want to leave it after you have burned $1 million in the cloud. You probably want to start very early on. But this is not a concern if you are on-prem, because again, you're not going to be using resources and then like finding a shock in your bill, because there is no billing to be handled here, because there is a hard limit on how many resources you can use because this is your hardware and you are paid for it. There may be some conversation you might have to have with your other departments in your enterprise, but again, the problem is very different here. It's not like you have to be worried about what might happen if I just let my instance run overnight. That I'm sure many people have already done. The third interesting thing is GDPR or HIPAA or PCI compliance. This is actually tricky to say that on-prem is all GDPR compliant. You can be on-prem and still not be GDPR compliant, and you can be in the cloud and still be GDPR compliant. It goes either ways. But the general perception is that, let's say you are traditionally compliant, you are compliant already, and you're on-prem. If you are trying to move to the cloud, then you have to revisit these guidelines, and you have to reanalyze what to see or run an audit to see whether your new service that is going to be running on the cloud is going to be compliant to your existing certifications. So that is something very important. Security is very important, data security especially. And so this is something that needs to be considered really well and before you move any customer data or critical data to the cloud. The last point there is constant loads. Let's say you have an application that takes one instance and it needs like 10 gig of RAM and 2 CPUs, and it's going to be running continuously for the next 2 years. The best use case there is to use a resource on-prem. There are, because you know that this is a constant use case, and the cost there is the best if you run on-prem. There are conversations about whether this is also feasible on the cloud. It is true. You can have a similar cost running on the cloud as well. but I would say it's on par. That is something that you need to consider along with the other concerns. So these are the considerations, cloud versus on-prem. As you might have noticed that I tend towards cloud use cases, and that is the needle is tilting a little towards the cloud in my talk, and that is I strongly believe in that. I have somebody saying lost the audio. Can somebody confirm if my audio is still there? SK, can you hear me?
Yeah, Pratap, your audio is good. That might be just a one-off case. Please go ahead.
Okay, good. Okay, so that is the differences in general between what makes sense in the cloud and what makes sense on-prem. But let's focus a little bit more on the machine learning workload or data science workload on the cloud, right? The first point there is for you to be able to do machine learning, you need the data, right? Data is what you run your machine learning algorithms on. So what we call as data gravity, right? So you can run your machine learning algorithms only in the location where you have the data. This means it's physical location, right? If your data is in on-prem, and if your data is, or let's say your data is on S3, on a specific region on AWS, that is the region in which you can run your machine learning workload, train your models. You cannot run these machine learning models somewhere else because you need to access the data. There might be even heavy access. So that is proximity to the data is probably very important. So what that means is before you can say that you can start to run your machine learning workloads on the cloud, you need to make sure your data is up and ready to be used on the cloud in the location that you are interested in. This also means that you might have to work with your data lake operators, administrators, and see if you can move your data to that location, to the cloud. That could also mean moving the data or actually collecting the data in the cloud itself, or have a secure connection, secure and fat pipe from your on-prem data storage to the cloud on wherever you're going to be running your models. So that is probably the most important aspect of moving running a machine learning workload on the cloud. Think about where your data is. You should also at this point consider frameworks. The frameworks, as in there are lots of newer frameworks that appear in the market almost on a weekly basis now. Right? We have H2O has released a 154 H2O driverless, which is lots of new features. So there are new frameworks that are coming in the market every week, and you might want to try that out. Right? There are new ML models, newer algorithms, newer upgrades, and being if you are in the cloud, this lets you try out your new technologies, new frameworks quite rapidly or instantly if you are in the cloud. Versus if you're trying to do this on-prem, you are now kind of stuck with asking somebody else to provision resources for you before you can start even trying things out. So that also could affect your time to market. Let's say if you are building something for your team and this is going to be delaying the process of creating new products. The third important thing is newer hardware. You also need to worry about what new hardware that you may need for your machine learning workloads. This could mean newer types of CPU, newer GPUs, or even TPUs. And this could you can also run quick trials and POCs on the cloud before you can even evaluate whether, and you can evaluate whether these technologies make sense, right, for your use case. There might be a much newer GPU that might make your workloads much faster, but with only like 2x times the cost, and overall it might actually be saving you money and saving you time. And you can make this evaluation on the cloud very rapidly. So that is also one of the things that makes it very attractive for machine learning workloads, especially to be in the cloud. But most important thing is machine learning workloads are, especially during the training phase, is a classic example of a bursty workload, right? It's impossible to tell, predict how much resources you need, very accurately. And it also, if you're running your machine learning training, you might be using like 8 GPUs for 2 hours, and then you could be shutting it down. And this is a very bursty workload, and does not make a lot of sense to purchase new hardware and have it in your on-prem data center just for this bursty workload, because your requirement could change very rapidly. It's best if it's in the cloud. It's what I would call a perfect marriage, right? So let's look at how driverless AI works in the cloud, right? So there are 4 steps here. I'm going to be showing like what are the components of running a machine learning workload, and which of these pieces of the machine learning workload can be in the cloud versus on-prem, and how does it look like, right? So there are 4 stages here. On the left side, you have what I have is pointing to several clouds that has the data. And for one example of this is Snowflake, which is a partner of ours. We work with them. We have Snowflake connectors that collects the data, and then you probably also need to work on data quality. You probably want to also work on the transformation. You could use Alteryx, also another partner of ours. This can be done on the cloud. Then the third thing that is of importance in this pipeline is what we call the driverless AI. It's marked in the gray box here, which includes feature engineering and then actually building the model itself, training the model. And this can be done on the cloud, on GPU instances and whatnot. Once that is done, you have the model that's built, and then you can deploy the model in the cloud, either on an instance, or you can have something like a Lambda function or a cloud function. All of these pieces can be done completely in the cloud. You do not have to be on-prem to any of these. And driverless AI is available on the marketplace in Microsoft Cloud, Google Cloud, and AWS, in all 3 of the clouds. Right. So this is one scenario where this could be it could be done. The next example is what is a hybrid use case, where let's say you want to use both on-prem and the cloud, and how could you use it? So this is an example where on the left side you see the data that is coming in from the cloud. This could be from Redshift on AWS, or it could be BigQuery on Google. Or it could be Snowflake, or it could be on-prem Oracle database as well. You need to collect this. So some of this could be on-prem, like an Oracle database. But you need to be able to collect this and throw this into create a data set, right? So this data set can either be in the cloud or this could be on-prem. This is the point where you need to worry about how are you going to transfer the data from the cloud to on-prem or other ways, right? But this can be done. You can use Alteryx or any data manipulation or data transformation tools. But the thing is, in the next phase, what I would call is a model building phase. I would highly recommend that you use the cloud for building your model. This is because it would be beneficial if you use GPUs, multiple GPUs, preferably. And this could save you time, but the bigger advantage is that you can do a GPU to time trade-off, right? Let's say you are in an urgency and you need to build a machine learning model like by the next 2 hours, and you can decide to throw in like 4 GPUs and get the job done, versus another day when you're not under time pressure. You could let it run on a lesser GPU or just a CPU instance overnight, and let it run overnight and see what happens the next day. But you get to choose this flexibility. You have this flexibility in the cloud, so that's why I would prefer if the model building capability is in the cloud. So if that is the case, then you would also have to make sure that your data is also being collected and transformed, or the final data is in the cloud. But the last part is, let's say after you've built your model, the model is just a Mojo file, right? Mojo or a Pojo file in Driverless AI or H2O. Now this can be deployed anywhere, right? This is just a very small file, And this can be this file can be served, or you can do the scoring or inference either on a cloud instance, or you can bring it on-prem and run it on an instance or run it on a hardware that you have on in your data center. The big thing is this is a good decoupling point here, right? So the model can be run anywhere versus the first three the stages of the pipeline are a little tightly coupled because there are a lot of data transfer charges, there are security issues, whereas this is a single file that is getting transferred, and so that is something to be to remember, right? The last case is that let's say if we have decided to move completely on-prem, you can have your on-prem data centers, data on-prem. You could use, it doesn't mean that you're traditional and you're not using the latest technology. You could be using a partner of ours like Minio, which gives you S3-like connections, data storage on-prem, right? You could be using Cloudera, you could be using Hortonworks on-prem to manage your, you could have a data lake on that, also do data transformation. But you could also run your driverless AI on your Intel servers with NVIDIA GPUs or even IBM hardware. So this is also supported, and we also have worked with several partners that are exclusively on-prem, right? So that is also possible. So it depends on really what exactly you want to do and what your goals are and what is your long-term plan to move towards the cloud or stay on-prem for various reasons, right? So I now hand it back to Vinod for the next slide.
Thank you, Pratap. So with that sort of understanding, right, let's look at how, as an example, right, we looked at H2O's driverless AI platform and see how that will sort of play out in an example, right? So let's say your driverless AI is the platform of choice for automatic machine learning. We do have a whole bunch of data connectors here. So as you can see, there's a bunch of stuff that's on-prem, some hybrid, some cloud. So you can bring in data from your HDFS cluster that could be running on-prem or even on like an Azure data lake, for example, right? So you can use either one. You can bring in data from your local file storage or something like Minio, as Pratap pointed out. But we also have connectors for things like Snowflake, Google BigQuery, and then Amazon Redshift, right? So you can bring in data from your cloud data warehouses to that. Once the data is in, it's sort of like once you've done the ETL and the data transformation prep, you bring it to what we call a modeling-ready data crate, right? So at this point, you have basically a bunch of features and a target, one or many targets that you want to predict. So that's your modeling-ready data set. And then at this point, you can then run Driverless AI to do a whole bunch of visualizations, and this is kind of the first step of your data science workflow, typically referred to as EDA or exploratory data analysis. Part of that is done by Driverless automatically. So we run through a whole bunch of these visualizations to find interesting things like missing data, any outliers in your data, look at the distribution itself, and find if there are any weird distribution patterns in there. Look at the cross-correlation across all the different features to help figure out if there are any strong correlations that are being seen even before you start doing the modeling itself, right? So that's good to know. And then you can go, based on what you find over here on the step, you can go back and fix the data set, if you will. After that, you run through the actual machine learning pipeline. And this is where we automate the whole workflow. So typically what this entails for data scientists is doing some feature engineering, which is basically transforming your existing features to make them more sort of well-suited for machine learning algorithms to take advantage of. Meaning that you might do things like of course, do things like basic things like one-hot encoding, do target encoding, for example, or you could combine a few features to create a higher order feature that's more well-suited for some of these tree-based algorithms or neural networks. Right? We do that all automatically for you. And this is where some of the sort of the art of the data science comes in as well, right? Where you might do these feature engineering steps in a way that's well-suited for the problem at hand. For example, if you see an IID problem, then you might do a certain set of transformations, whereas if you see some time series data sets coming in, you might do things like creating lags or window features that look into the past for detecting micro or macro signalities. So those are kind of the things that we could do in Driverless AI automatically for you. Finally, after that, you run through a whole bunch of algorithms to find the right set of models, and then you tune those models as well. So this is an iterative process. Do this feature engineering, try algorithm, tune the model, and then see how the performance is, and you go back to the drawing board to do that again and again. And over time, you get a pipeline, basically, which is highly optimized set of features, algorithms, and the tuning parameters to sort of fit the problem really well. Once you have that, there's sort of two next steps. The first step is to actually generate the model pipeline. This is what will go into production. Your scoring engine or artifact that is either in Python or Java in this case. We provide both those options. And you can then deploy this model into kind of like a real-time scoring environment with the REST server, if you will, or deploy it on cloud, for example, as a Lambda service. You could also do batch scoring with it. And then you can have things like, this is where some other things that I mentioned earlier, like having some elastic load balancing, putting it in a different place for a cloud environment for scoring would be useful. We also then do machine learning interpretability on the models, which is a good way to help understand how the model actually performs, meaning understand what the top reason codes for each prediction and use that to sort of go back and revisit if the model is doing the right thing. Meaning, if you see that there are certain features that are coming out as significant, which shouldn't have, you can go back and tweak that in the pipeline. So this is extremely useful for diagnosing and detecting bugs in the model or helping get a feel for the fairness or any bias that might have crept into the model. So that's a very important part, and we do this again automatically for you. We generate these interpretations for you. Right. So at this point, I'm going to skip into an example of a customer. So this is one of our really valued customers called G5. You can go to the website getg5.com to learn more about what they do. But at a high level, they are a real estate marketing company. The service they offer is for operators or property managers. So their customers are property managers who manage single-family or multi-family properties or senior living facilities. And what they're trying to do is manage their advertising campaigns. So they are running ads, let's say on Google or other social networks, and they get generating leads out of those ads. And based on those leads, they have to qualify those leads to find out which ones are most optimal for actually who are interested in buying or renting the property, and pass them on to the property managers. So this is the sort of use case that they are trying to solve for their existing clients. They're based out of Bend, Oregon. They have about 250 employees and a very lean but sophisticated operation. So the goal for them was to detect from the call or email or touch point from customer from a prospect and figure out if that lead is a hot prospect or not. And how do they do that, right? So they're trying to measure the marketing efficiency, but also do the lead qualification so that their existing clients can actually go after the hot leads very quickly. So what that basically translates to is it's kind of basically intelligent lead scoring, but also parrot back to help optimize your marketing spend. So as your leads are coming, you can optimize and see if basically if your lead scoring is telling you whether the leads are good or not. And if they are, then you spend more on the channels that are giving you the better leads, and then drop spending on the ones which are not. So it's doing this all in a real-time fashion. So how do they achieve this? So their infrastructure ended up being completely on the cloud. So what they did is as the calls were coming in, these calls were being stored as audio files. And then these calls were stored into Amazon S3. So they had these call files coming in, and then they were using a transcription service to take the audio file and convert it into text. So you have basically a text transcript of the call. And then they were using H2O's, H2O3's word-to-vec model to generate features, basically meta features representing the key sort of word embeddings in the call. And these were then generated on EC2 with H2O3 running there. Once they do that, they pad it with some metadata about the call, things like the duration of the call, the time of the call, day of the week, time of the day, which area the call came from, origination area, and things like that. And those metadata, along with the features from the actual call transcript itself in the word direct model, combine those two and pass to driverless. And they did all this comes a combination, basically, the data prep in Amazon EMR, basically using EMR to generate a cluster and then run H203 on it to do this data munching using Spark plus H2O. Once that was done, they ran it through H2O Driverless AI to build a model that would basically use all this metadata and the call transcript features to predict which calls were highly likely to buy or had higher intent of purchase. So find the caller intent very efficiently for this. And once that was done, those models were then deployed using AWS Lambda to score on real time. So what that essentially translates to is basically a real-time sort of application where it takes a phone call, transcribes it, vectorizes it, then scores it on the new, it scores the call transcript plus the metadata with the model built by Driverless and gives you a call score. And that call score essentially populates their scorecards, which are used by their end customers to see if a call is hot or not. So you'll see something like this where you can see that the hot call might be ranked color-coded to ensure that this person is a hot prospect, go after them. And what that boils down to is essentially a business outcome of basically, it came to $1 million plus savings per month out of the box, right? And the key to remember is they were able to do this with a staff of just 2 technical folks. These were basically data engineers and 1 data scientist team. But essentially, a very, very small data science team was able to pull this off in a matter of a couple of months. And there is a few reasons, right? First is that entire data science workflow is completely automated using Driverless AI. So they got the power of an expert data science team in a box, essentially doing all the machine learning work for them. And that resulted in like a really highly accurate model, like a 97% AUC on the holder. That's actually better than even having a team of humans evaluating those calls and evaluating whether the caller intent was good or not. So in this case, the model was actually beating, they had a team of humans and a call center doing this evaluation that was beaten by them. But more importantly, because they chose an infrastructure completely on cloud, using cloud-native elements, but also using software like H2O3 and Driverless AI, which are already available and optimized for them, they were able to put this entire infrastructure up in place in a matter of months. So in a couple of months, they did the whole machine learning plus the infrastructure to set up this application and generate savings. And this goes to show that this is not just a theoretical thought experiment. You can actually pull this off, even for good medium-sized companies or even large companies. And I can learn more about that particular use case in a previous webinar that we did with AWS and G5. We'll put the link in the notes and follow the email. So basically, at this point, I want to invite Pratap to share some thoughts on what should a new cloud consumer remember for any practical implications on some of the things we thought about. So do you want to talk about these?
Sure, yeah, absolutely. So let's say you're a new cloud user or you're just creating a new account. You may be a existing cloud user, but you're trying out something in a new account for a new project. These are some things to remember. That is, first is start small, and then you can go bigger, right? One of the mistakes that I did initially was when the GPUs first came out, I really wanted to try them out. I started with the largest instance type, and I was doing something, got distracted, and then came back a week later and found that this instance was still running. So you don't want to do those kinds of mistakes. I'm sure many of us have done that. So start small. You can even use just a CPU-based instance maybe. Also try to use auto shutdown. There is a feature called auto shutdown which says that if the CPU is not getting utilized for more than 1 hour, it would automatically shut it down. So if there is a feature available in the cloud, AWS has it. So if you have that feature, you can shut it down. The second is, let's say you're going beyond just one instance. You want to make sure that you want to minimize orphaned resource. An orphaned resource is something you start and then you forget to shut down, and then you move on to the next project and so on. These are resources that are being billed for, getting utilized. But the thing is, even if you have more than one person in the team doing this, you would actually forget who started what, and there will be lots of resources running that are mostly unnamed, right? It'll be like instance 1, instance 2, and so on. And nobody would remember who exactly started these instances. And everybody would think it's somebody else, and you would not want to shut these down. This actually is like completely wasted resource. You don't want to do that to avoid having any shocks in your bills, in the monthly bills. Administration of resources and data, have some kind of a basic administration. That is, do not use root account for your clouds. Always use an IAM user, which has lesser privileges than a root, because root account has all the privileges, can do everything in the account, in the cloud account. Always use an account that has lower privileges. Make sure that the privileges are actually as minimal as possible, and have privileges only as needed as possible. If you do not need to have unnecessary privilege to access resources or services that are completely unrelated, like just do not even have that. Fourth is have some basic security practices in place. Like let's say you're starting an instance, like for example, if you use AWS Driverless AI, it runs on port number 12345. Very easy to remember. But the thing is, you only need that port. You do not need all the other ports. So by default, when I create the image, I do is I only open that port, and all the other ports are shut down, right, or blocked. And you want to use very simple, right? And even that port you can configure to be accessed only from your device, your laptop maybe, right? You don't want to open all your ports. The worst thing is to opening up all your network ports to the entire world, right? That is like inviting trouble. The thing is, fifth thing you want to remember is cost estimates, right? When you are launching an instance or launching some resources, there are two pieces to the estimates. One is infrastructure, that is the instance type, and probably the volume, storage volume that you're attaching and so on. That is all part of the infrastructure. And there is also the piece for software fees or licenses. Mostly they would separate and show you these and then add and give you the total. You want to be aware that these two are separate, and the fees for infrastructure varies by the size of the instance. The software fees might not be like that, might not be linked to that, might be orthogonal. You want to be aware of what exactly you're doing, how exactly is it going to be billed, right? So this is usually something that's shown to you before you launch, or at the last step of launching an instance or resource, right? And the last thing that you want to consider is portability, right? Let's say you're working on a machine learning platform problem, and you're choosing a cloud. You want to make sure that, and let's say this is not finalized. You do not know if this is the cloud you want, or if it's even will be in the cloud or in the data center. You really want to make sure that your project that you're doing, you're not painting yourself into a corner. You cannot say that, hey, at the end of this POC, you cannot say that, oh, it only works on this cloud, and it's not portable across the cloud, or you cannot bring it on-prem. This is something that is that you may not feel initially, but this would be a project-killing factor that would eventually damage the project's long-term vision, right? Long-term growth. So what you would ideally want to do is choose a platform, a machine learning platform that is portable across the clouds, and also it's portable on-prem, or even portable and bringing it to your own laptop. So we actually in H2O make sure that all of our products are like this, right? All of our products, Driverless AI, H2O, they can run anywhere. They can run on your laptop. They can run on-prem on a Intel CPU on a data center, on your own data center, or it will run the same software. You can run it on any of the clouds, any of the public clouds. So you have this portability. So you have this. You don't have to worry about, hey, am I painting myself into a corner by choosing to run a trial run on like one cloud? You don't have to be worrying about that when you're using H2O's products, because it's completely portable across clouds and on-prem, or even on your laptop, right? So those are some things to remember when you are evaluating or just starting up with running a workload on the cloud. Vinod, do you want to take over this slide?
Sure. So again, if you're starting with H2O on the cloud, if you want to do that, you have quite a few options, right? So all the three major clouds, AWS, Microsoft Azure, and Google Cloud, we are available. And all three products are available. So if you want to use H2O Core, there's a VM for H2O Core on all the three clouds, the AWS Marketplace, Azure Marketplace, and Google Cloud Marketplace as well. Similarly, Driverless also is available in all the three clouds, and then Sparkling Water is available as an integration to the cloud-native big data infrastructure packages. So, for example, on AWS, we have Sparkling Water plus EMR CloudFormation template that you can use to get started very easily. On Azure, you can use the Sparkling Water on HD Insights offering to get started on a big data cluster and do your machine learning on with Sparkling Water. Similarly, on Google Cloud, you can use Sparkling Water with Dataproc, which is Google's own native big data infrastructure solution. So as you can see, there are cloud data solutions which are very optimized for the specific ones. And finally, it's just screenshots of the three marketplaces. You can go ahead and pick it up. In addition, we also have a couple of offerings especially for customers who want to get started on a quick trial. So if you want to do a quick trial or a POC with H2O's offerings, you can do a couple of things. The first you can do is try a test drive of H2O on AWS with an offering called Aquarium. That's our training platform. So you can, if you have been to one of the H2O conferences or H2O trainings, you probably have had a chance to play with it. But that's a very quick way to try Driverless or H2O3 on a cloud instance for a couple of hours to go through a training. We also have something called this Puddle, which is available for trials and POCs. So if you're interested in trying out one of our offerings on kind of like a cloud-native interface without having to go through your own setup, you can try that as well. So if you are evaluating running H2O on H2O's products on cloud, that's a quick way to try it out. So contact our sales team or one of our marketing folks, and we can set you up with either of those two. Okay. With that, we've come to the end of the presentation. I think we have a few minutes for taking a few questions. Let's look at the questions that are coming up. Right. So there's a couple of questions that came up, both online and offline. So there's one here. So I think we answered the first question. That was basically, is H2O and Driverless AI available on all the clouds? As we said, yes, they are available. H2O3, of course, is open source, so there is no license cost for running H2O3 on any of the clouds. You only have to pay for the infrastructure. If you do want to buy enterprise support for maintenance and helping you through the AI and machine learning journey, we offer that for our H2O Sparkling Water customers. So that's available. For Driverless AI, we offer, again, the VM itself is free on all the clouds, but you have to bring your own license. So if you got a trial license from us, you can use that on those cloud instances. And eventually, if you do end up buying a commercial license from us, you can use that license as well to run on the public clouds. So we are old model. So hopefully that answers the question. The second question here is interesting. So basically, it's basically the question is how to pick the right hardware or instance type for a particular ML workload. This can be a little tricky, right? Because you need to understand what the sort of consumption patterns are for the ML framework you pick. So, for example, for H2O Core, we typically recommend compute and memory size requirements based on the size of the data set. And typically, it's a multiplier. So if you have, say, a 10 gig data set, we recommend at least 4 to 5x the amount of memory for managing that to run that in an efficient fashion. And of course, compute is also a separate consideration. So we provide these sizing guidelines, and oftentimes, and most likely, most enterprise-grade frameworks will have some kind of a sizing guideline. So it's probably useful to figure out what the size of data set you're going to run, and find those sizing guidelines from the vendor you're choosing. In our case, in H2O's documentation, we have sizing guidelines for both Driverless AI and H2O3. You can use that to pick the right hardware instance. And that's the benefit of doing it in cloud. Let's say if you find that your experiment is really slow, you can always shut it down and spin up a bigger instance. And that's tough to do on-prem, right? You have to make the decision up front, whereas here you can try out. It's easy. It's cheap to make a mistake. You can shut down the instance in an hour and then go and start a new one.
Okay, Vinod, just to add to that, I think
sure.
So you captured all the considerations or factors for sizing the instance during the training phase, right? I think you had a very interesting scenario with the customer use case G5, where the deployment phase, like after you're done with the training, and then you're trying to deploy the Mojo or the model, now you don't have to have such a large instance type, right? You only need to have a much smaller instance type. And also you can even deploy it into a Lambda function or a cloud function, which could bring down the cost even further. But the type of workload now with the deployment is very different now, right? Because it's going to be continuously up. And so this is going to be a smaller instance, but continuously going to run, versus the training phase is a bursty load. You might want to have, like you said, 5 times the memory requirement of the data set, but the deployment can be much smaller.
Excellent point, Pratap. So that's definitely something to consider as well, right? Again, find out the spec of design pattern for your application. So if you do, what kind of latency do you need for inferencing? What kind of how is it? Are you doing batch scoring or real-time scoring? And having a good understanding of what your sort of end user requirements are on the inferencing side can help pick the instance type or function type for that. And as Pratap mentioned, that can be a much cheaper instance but it's going to be running all the time. So the considerations there are a little different. So having a good understanding of what kind of data you want to bring in and what kind of model application you're trying to build will help you size these. So I think we have time for one last question, Pratap. Maybe you can take this one. The question is basically, how do you migrate the data from on-prem to the cloud? Are there any sort of best practices around it?
Yes, absolutely. So, like I mentioned before, if you are trying to run your machine learning workload in the cloud, you want to make sure that the data is in the cloud, right? You cannot run machine learning without the data. This is not reinforcement learning where it's just exploring the space. This is building models from data. So there are a couple of ways. First thing is that you can move your entire data collection pipeline, ingestion to processing to storing, into the cloud. That is a very cloud native way of doing things. But if that is the case, I think that is a trivial answer for this. This question is based on the fact that there is some data that's outside the cloud, right? So in that way, there are 2 things. One is you can migrate the entire pipeline to go on the cloud. That includes, again, ingestion, processing, and storage. The second way is to have some kind of ingestion pipeline on-prem, or whichever part that is on-prem, you stay on-prem. And what you can do is to have a final output file or single file or a bunch of files that can be securely transferred to the cloud. If you all remember, transferring data into the cloud is free mostly, because data in is always free, data out is expensive. That can be done. But the problem with this case is that now you're taking data from on-prem and transferring it out to outside your data center. So this is going to raise a lot of red flags in your security enterprise, right? Cybersecurity team is going to flag this. This is not the best way, but that's what we would think, right? So, but the ideal use case is to build a data lake solution that's boundaries includes your data center as well as the cloud, by having a secure link between your data center and the cloud. You can use for AWS, you can use DirectX connections or a secure VPN connection, whereby now you have a pipe from on-prem to the cloud. If you have this, then the situation is very different, where the data can freely move between your on-prem to your cloud, or you can bring it even on demand. Like, let's say just before you start your machine learning modeling or training, you can pull the data from either the cloud data lake, or could bring it from your on-prem data center. But the idea is that you have the boundaries of your data lake does not stop with your data center is the important thing, and data security is the main thing to consider here. You do not want to transfer data directly to the cloud, which is not the good best practice, right? So you want to work with your cybersecurity team to make sure that is available.
Very good.
Okay.
Thank you, Pratap.
There was one question. Yeah, go ahead.
Yeah, I was going to take the one question about do you guys support REST API endpoints for the train ML models? So the short answer is yes. but in the way that we basically provide you the artifacts for generating, spinning up your own REST server. So we provide you a thin file with a wrapper, and you can use that to spin up your REST server. And if you go to your documentation, and we'll send those links, we have a whole bunch of sort of deployment templates published, which include tips on how to spin up your REST server, how to set up some functions, load balancing, maybe think of other considerations. So those are all available. If you use the current version of, latest version of Driverless AI, we also have a one-click deploy to AWS Lambda, and then one-click REST server is coming very soon. So it's available in the release batch, but it will be available very soon. So we are going to have these one-click support, one-click deploy type templates available very soon. So, Pratap, you had something else?
Just last question that somebody is asking about if the slides will be ready for viewing later on.
Yeah, so all the slides will be provided, and the recording will be sent to all folks who are registered for the session. So that'll be good. Okay.
Right. Thank you, Vinod and Pratap, for taking the time and doing a wonderful presentation. To add to the availability of slides and the recording, they'll be available at the same URL you came in for the webinar, and they'll also be. You can also find that on our BrightTalk channel. Again, thank you, everybody. Have a good day.